Hello students, welcome to my channel. So I have completed many topics in this chapter of metals and non-metals, and today we'll discuss on the occurrence of metals. So metals, you come across in your day-to-day life. Very often we use metals for our day-to-day activities. Let me start giving you some examples. When you enter your house, the grills of the door or the window are made out of metal, either iron. So many other uses in your houses. Let us enter the kitchen. So in the kitchen we use spoons, plates, utensils, vessels, and so many other things. So even your transport vehicles, okay, either your two-wheeler, car, whatever, is made out of metal components. So there are other uses also. If you go to the gym or some family member of yours goes to the gym equipments are made out of metals, out of metal components. So you can see there are so many uses of metals, so much wide range applications of metals. Also in industrial purpose, so many application in construction work, building of bridges, okay, in construction, even building of your own houses is made out of metal. There's a metal structure and on that cement or concrete is laid. So there is so much of wide range application of metals that we should observe and notice in our day-to-day life. So all these metal components that we use for our day-to-day activities, for our uses, from where do they come? I mean, from where do we get these metal components? Yes, we do get it from industries. Manufacturing industry make these components for us, these products for us to use. But from where are these metal got? Where are these metal? They are made in the factory, they are made in the industry. But from where do these metal components, from where do they occur? So let us understand this in this topic. So let us understand how are these metals got. So consider there's a region, just for you all to understand. So there is something called as mining. So a specific area or a region, a specific area is rich in a certain metal, and so this soil, the land, that particular area, they go and mine. So minerals, it is rich in minerals, and all this occurs on the crust of the earth. It is on the outermost layer of the earth. So these are rich in minerals. Minerals are either elements or compounds, and this soil is rich in minerals. So minerals can be of many different types, variety. So in a specific area there is extra percentage of a particular metal in that mineral. For example, this area is rich in iron. So this particular area will be mined for iron, and many other minerals also, metals, that can be got to this. So this is called ore. It's called the mining of the ore, with many minerals being included in this, and through the processes that happen in the industry, different processes, one after the other, from the ore the metal is got. So let us understand this and study this in detail. So let us go back to what we have studied earlier in our previous topic, the reactivity series of metals. So to understand which metal is more reactive than the other, it's the comparison. This reactivity series is helpful. So metals of different types arranged in with their reactivity series from the most reactive to the least reactive. So the ones that are sodium, potassium, the other metals which are most reactive are extracted through the electrolysis process. And metals occur on the crust of the earth either in its pure form, pure metal, or in the combined state. So metals that are least reactive like gold and silver, which come below in the reactivity series, and copper are available in their free state, in their pure natural state metals, also sometimes in the combined form. So least reactive metals like copper, silver and gold, they can occur in nature in their free state, in their pure natural form, pure metals, or either in the combined form. So if it's in the combined form, copper and silver, they occur either in the sulfides or oxides ore. So the metals which are least reactive, which are bottom in the reactivity series, can occur in their pure state or also in their combined state. So the metals which are above in the reactivity series are so reactive that they never occur in their pure state. It's always in the combined state. And the metals in the middle of the reactivity series are moderately reactive, so they occur in the combined state of sulfides, oxides or carbonates. So let us understand how extraction happens through the ores. So now let us understand how the metals are extracted from the ore. So prior to the purification process and the extraction of the metal from its ore, the ore it consists of lot of impurities like soil and also sand particles. So these impurities are called gangue. So it consists of soil and sand, many unwanted particles, unwanted matter. So this has to be eliminated from the ore prior to the process of extracting the metal from its ore. So depending on the properties, the differences in the properties, physical and chemical properties of the metal and the ore, so depending on the differences, the specific process is being applied to purify, to eliminate this unwanted matter. So now let us understand, in the reactivity series there were most reactive metals, so moderately reactive and very low reactive metals. So now let us understand the metals that are medium reactivity, that is iron, zinc, lead and copper, how the extraction process is being carried out for these metals. So these metals are of medium activity, so they are not very reactive and not very low reactive, they fall in between of the two. So prior to the extraction, to get the metal in its most simplest form would be its oxide form, the metal oxide. And most of the metals in nature are in the form of its oxides, metal oxides. The reason is because oxygen is so reactive element, and also it is present in abundance on the earth. So because of its presence and also its reactivity, most of the metals are in the form of their oxides. So when they are in the form of their oxides, the metal, it becomes much easier, much simpler to extract that metal. So prior, these metals are in the form of carbonate or in their sulfide form. So for when it's in its sulfide form, the process of roasting is being carried out. So in roasting, it is heated with air, excess amount of air, and so this process is called as roasting. So in the carbonate form are heated in the presence of air, but limited quantity of air. So that's the difference between the two, calcination and roasting. So after the process, it forms oxide of the metal, and the further process is reduction to metal and the purification process. So remember this flow chart. So if you remember this, then you can understand the process which is applicable for the medium reactivity metals. So now let us understand the metals of low reactivity, how they are extracted. So the metals that are low in the reactivity series, these metals are very unreactive. So just by a heating process, the metal can be extracted from its metal oxide, from its ore. So let us understand metals of low reactivity, which are sulfide ore. Just by the heating process, it is converted to its metal oxide, and furthermore heating, that is called roasting, the metal is extracted, and furthermore process is refining. So let us understand this with the help of two examples. So with these two examples, cinnabar, which is an ore of mercury, is converted to its metal oxide with heating process, and respectively this metal oxide, again when it's heated, it is converted to its metal. So another example, similar reaction that happens with copper. So copper present in its copper sulfide form gets converted to copper oxide in the presence of heat after heating, and it is converted to copper, the metal, after heating. The copper oxide gets converted to copper. So both these examples show the similar reaction where a metal sulfide is converted to its metal oxide, and again with heating the metal oxide gets converted to its metal. So both with mercury and with copper, we have understood in this low reactivity of metals, just by heating process it gets converted to its metal oxide and this ore, and just through the metal oxide the metal can be extracted. So now let us understand how the extraction happens with high reactivity metals. So the metals that are high in the reactivity series are very reactive metals. So just by a heating process similar to what we learnt, this metal you cannot extract it from its ore. So just by heating these compounds with carbon, you cannot extract the metal from its ore. So the reason is because these metals have more affinity to oxygen than carbon. So just by heating it with carbon, you cannot extract these metals from their ore. So these metals have to be extracted from their ore by a process called as electrolysis. So metals such as magnesium, sodium and calcium, which are very reactive metals, these metals have to be extracted from their molten chloride through electrolysis process. So it's at the cathode, there's the metal that is deposited, and at the anode it is chlorine. So let us understand this with the chemical representation. at the cathode, it is sodium metal that is deposited. The cathode is the negatively charged electrode, and at the anode, which is the positively charged electrode, there is liberation of chlorine. So here's the chemical representation. At the cathode, negatively charged electrode, there is sodium metal that is deposited, and at the anode there is chlorine liberation. So these very reactive metals, they cannot be extracted just by heating mechanism similar to the medium reactivity and the low reactivity metals, because these metals have more affinity to oxygen. So just by heating it with carbon, you cannot extract the metal. So this has to undergo electrolysis process. So the metals that are obtained from these various refining process, these metals are impure, so they need to be refined, purification of metals. So this is done by electrolytic process. In this there are two electrodes. So one is the anode and the other is the cathode. So consider two electrodes, anode and cathode, in an electrolytic solution. So here it is copper sulfate So consider two electrodes, one is the cathode and the anode, in a solution of its metal salt. So in this it's copper sulfate, and the two electrodes are the impure copper metal is the anode, is made the anode, and the pure a thin strip of copper metal is made the cathode. So what happens, the impure metal, it gets dissolved in the solution of its metal salt, and the pure metal gets deposited at the cathode. So the impurities which are not dissolved in the solution deposits down, and this is called as the anode mud. These are the impurities because this metal is impure, and the ones that get dissolved in the solution are in the solution. The ones that are cannot be dissolved, they get deposited, these impurities, and they are called as the anode mud. So through this process of electrolysis, the pure metal is got. So if you all have any queries or doubts regarding this chapter or any of these topics which I have completed, don't forget to drop your comments below. I'll try to reply to you all at the earliest, and I'll continue with my next topic of corrosion.